between one task to another task. So 3 benda tu lah. So another 3 things that you need to know in this topic ialah granularity, concurrency and task interaction. Ada 3 benda lagi. Okay. So what is granularity? So granularity is the number of So granularity is the number and size of tasks into which a problem is decomposed. It means the granularity of decomposition. Granularity ni cerita besar mana size yang pecah-pecah tu. So you decompose daripada task yang besar into a smaller task. So how small is small or how big is big. So itu granularity. So a decomposition into a large number of small tasks is called fine-grained. Ada certain orang dia ada certain task we can decompose it into a very small task. So this called fine-grained. Ada pula yang jenis dia decompose into a small number of large tasks. Task dia besar, contoh awak pecah pada 2 je. Satu task besar awak bagi 2. Okay, itu dipanggil coarse-grained. Bilangan task sikit tapi satu task tu banyak benda kena buat. Kalau fine-grained, bilangan task banyak tapi task yang nak kena buat sikit. Itu 2 benda lah. Okay. So ini dia kata contoh figure 3.4, decomposition of dense matrix, multiplication into 4 tasks. The portion yang ini contoh kalau you buat guna coarse grain. Tadi kita tengok contoh yang fine grain. Setiap row kita pecah kepada satu task sahaja. Itu fine grain punya example. This is an example where a coarse grain punya decomposition. Awak pecah kepada 4 task sahaja. So setiap task akan dapat 3 ke 4 row macam tu. Okay. So number of tasks small. But the task that you need to be done is bigger or larger. Okay. Itu granularity. So kita abstractions of the task graph of figure 3.2 and 3.3 respectively. Yang ini contoh task graph untuk yang database query tadi. Okay. So dia kata a feature of task dependency graph that determines the average degree of concurrency for a given granularity is critical path. So ini adalah task dependency graph yang sebelum ni kita tengok untuk database query punya problem. Ingat tak yang database query tu yang pasal civic 2001. Okay, ini yang case 1, cara 1, ini cara yang kedua. So daripada task dependency graph kita boleh determine the critical path. Okay, apa dia critical path? The longest directed path between any pair of start and finish node is known as the critical path. So mana yang paling longest? So itu adalah critical path. In case A yang paling longest memang kita tahu ada 3 sahaja. Sama ada pergi task 4, task 6, task 7, task 3, task 6, task 8, that's all. Dalam this case the longest, yang case yang B case, the longest is we go to task 1, task 5, task 6 and task 7. That's the critical path. Okay. So yang kedua ialah the sum of the weight of nodes along this path is known as the critical path length, where the weight of a node is the size or the amount of work associated with the corresponding task. So associated with critical path is critical path length. So critical path length ni apa? Awak tengok weight dekat task, then you calculate the total weight. So that is the critical path length. So kalau dalam case B, it's clearly, we know that it's clearly task yang ini yang paling panjang. Okay. Kita ambil. Okay. Yang ni yang paling panjang, task ni, task 1, 5, 6, 7. So this is the critical path length. Critical path, Critical path length ialah we sum the weight of the task. Kenapa nak sum the weight of the task? The weight of the task represent how much work need to be done in this task. So kalau ikut yang case B, the punya critical path length is 10 plus 6 plus 6 plus 11, 16 campur 11 jadi 27 campur dengan 7. So dia dapat 34. So this is the answer. 3 pahalan. So in the situation A situation, kita ada dua yang ada 4 ketiga pahalan dia. So which one yang kita nak ambil? Ketiga pahalan 4, which one yang kita nak ambil? Ambil yang the longest. Maknanya yang paling banyak critical pahalan dia. So kalau ikut kat sini yang paling banyak ialah 10 plus 9 plus 8 would be 7. Yes.
27.
Ini yang paling panjang lah. So the critical pahalan is 27. And then we can also determine the total amount of work. So awak nak tahu mana yang paling bagus. Salah satu cara dia ialah you can calculate the total amount of work lah. Berapa banyak tugas yang boleh buat, sebab dua-dua ni sama, nak cari benda sama. So macam mana nak kira total amount of work? Awak tambah semua weight ni. Awak tambah semua weight, then you will get the total amount of work. And the last part ialah degree of concurrency. Degree of concurrency, how to calculate degree of concurrency? Degree of concurrency yang ini dia ambil total amount of work divided by critical path length. Then you will get the degree of concurrency. Mana satu bagus? Degree of concurrency makin tinggi ke makin rendah paling bagus? Kau rasa makin tinggi makin rendah? Makin tinggilah. Makin tinggilah. Maknanya apa degree of concurrency? Makin tinggi dia boleh buat kerja secara concurrent. Maknanya dia kata A ni, cara buat kerja macam cara A ni, awak boleh buat secara concurrent sebanyak 2.33 degree. Kalau yang ini awak boleh buat secara concurrent hanya 1.88 degree. The main purpose of parallel platform atau parallel algorithm, kita nak buat satu-satu task tu secara concurrent. So itu dia punya kisah lah. Okay, ada soalan? Okay, kalau ada soalan awak boleh post dekat chat, tak apa, saya tengok nanti. Kita boleh tengok nanti. Ada ke orang post dekat chat? Tak ada. Okay, next kita sambung sikit lagi. Last part is task interaction graph. The last part is task interaction graph. Okay, let's say kita cerita tadi ya pasal kita dah tengok on granularity, dah tengok on concurrency. Okay, kita dah tengok on concurrency lah kan. Okay, next is task interaction graph. Okay. Other than limited granularity and degree concurrency, there is another important practical factor that limits our ability to obtain unbounded speed up, which is, what does it mean with speed up? Speed up is the ratio of serial to parallel execution time. So biasanya kalau kita nak buat parallel ni, kita punya task tu boleh disiapkan lagi cepat daripada awak pakai serial komputer. Komputer biasa, komputer parallel, mestilah kita nak yang parallel ni lagi cepat. So the ratio of the time, the execution time antara serial dengan parallel, we call them as speed up. Okay, we call them as speed up. So apa lagi yang melimitkan the speed up? This factor is the interaction among tasks running on different physical processor. The task that a problem is decomposed into often shared input, output, or intermediate data. For example, in the decomposition for matrix vector multiplication, although all tasks are independent, they all need access to the entire input vector B. Since originally there is only one copy of the vector B, tasks may have to send and receive messages for all of them to access the entire vector in the distributed memory paradigm. So the pattern of interaction among tasks is captured by what is known as task interaction graph. The node in task interaction graph represent tasks and the edges connect tasks in the interaction with each other. Okay, ada satu lagi part graph yang awak kena tahu ialah task interaction graph. Apa dia task interaction graph? Task interaction graph dia show or represent a communication between the tasks. So the graph will show task mana yang akan communicate dengan task mana. Kalau task dependency graph, it talks about dependent antara task, dependency between the task. Dependency maknanya kena siap A baru boleh buat B. Bergantunglah kan. Tapi interaction maksudnya which task that need to communicate. They have to communicate. Nak communicate sebab apa, madam? Antaranya ialah bila they have they share resource dependency. They share resource. Contoh dalam this problem yang kita tengok sebelum ni, dia guna multiplication where you have to share B among the tasks. Awak kena share B among the tasks. So kena communicate. Okay, this is another example. Sparse matrix vector multiplication. Apa contohnya ni? Okay, dalam contoh ni dia sama matrix vector multiplication tapi sparse matrix. Maknanya bukan semua matrix yang akan didarab. So mana yang dia akan darab? Dia akan darab yang dot-dot hitam ni sahaja. Orang nampak dot-dot hitam ni kan? So dalam task kosong yang akan darab dengan B hanya 0, 1, 4 dan 8 sahaja. Okay. So graf sebelah ni graf pasal apa? Graf ni adalah graph of the task interaction yang mana yang akan communicate between each other. Kalau kosong, task kosong dia akan communicate dengan 1, row 1, row kosong, row 1, row 3 kosong dia akan pergi ke 1 and then dia akan pergi ke 4 and dia akan pergi ke 8. And then task 2, task 1 need to communicate with 0, need communicate with 1, need communicate with 2, 5 and 6. Boleh nampak apa dia punya ni? So kalau yang